Then today we are going to start new chapter, that is lesson number 10. Lesson number 10. The name of the topic is visualizing solid shape. In the previous class, we have learned about the various type of figures, like that is one dimensional, two dimensional, and the three dimensional figures. We have learned in our previous class. See, we will recall few points about define these three dimension. One dimension means figure having only length. This type of figure we call as one dimension. And about the two dimension figure having length and breadth. If the figure has length and breadth, we can say that type of figure we call it two dimension. The three dimension. What do you mean by three dimension? Three dimension means figure having length, breadth, and height. One dimension means a figure which have only length, and two dimension means a figure has length and breadth. Three dimension means a figure having length, breadth, and height. So in this visualization of one dimension, we can say that the example of one dimension is line segment. Two dimension, we can say that the rectangles, and the three dimension, we can say example as a cuboid. So in this visualization of 2D shape, their representation on paper is very convenient. However, the tricky part is visualizing a 3D shape, representing it on the 2D sheet of the papers. If we 2D, if we want to visualize the 2D shape, it is very easy. If we want to visualize the 3D shape, it is very tricky part. So we are going to learn this 3D shape to visualize a 3D shape. Okay, in this lesson, let's see. Here, before we start, we have to understand what is solid. A solid is bounded by a one or more surface, and it is always occupies some space. Its surface means a face, okay, can be plane or a curved surface. When two faces of a solid meet together, we get what? We get a line segment, that is we call it edge. When the three or more faces of solid meet at one point, then point is called a vertex of a solid. This is a definition and a define of solid. So in this part, in this lesson, we are going to visualize a solid shape. So we have to understand what is solid first. What are the edges? What are the vertex? What are the face? I think we have learned in the all in our earlier classes. Here is another point we have to understand: perspectives. Perspective is art of representing solid object on a flat surface to convey the impression of the height, width, depth, descent, etc. You see here there are two pictures. This is a Parliament House, and this is another pictures. So the word perspectives come from the Latin word that is perspectiva, or the science of the optics. Perspective is of a great importance to the artists, painters, and the architects, etc. This is how we can say this is a perspectives of the flat surface to convey the impression of the height, wide, depth, descent, and etc. Okay. Now, how with the halo oblique lines and the shading, the 3D effect is captured in the 2D. Objects which are supposed to be near are drawn larger, and the objects which are supposed to be farther are drawn smaller to give the effect of the distance. This is how the definitions of perspectives and how it works. Okay, so this is another point including in this visualizing shapes. Next, we have about the different view of the solid shape. Suppose we have three cubes, one on the top of the other, shown in figure. This one. These are three cubes. It was one upon another. Okay, one upon another. The cube we are have been put in the one upon another. If we look at these solid structures from the top, what will you see? When we look from the top, then we will see only this square face. Okay, we will see only the face of the top is square, just as that is just as a square. We can see as a square. But if we look at it from the side, left or right, what we could see, shown in the figure 14.4, this one. When we look at from the side or from the left or right also, we will see this shape. This shape is in this case the front view would also be the same. Like in the top, the front view also will same. That means we will see in the form of square. So let us draw the front side top view of the following solid shape. See, this is another solid shape. If you want to draw the front shape, then we will draw this type, because we have draw trees. We have to draw the tree square. If you want to see in the side view, then we'll draw these two square. In the top view, we will see this one and this one. Here one, here one. So we will have to draw two square. In this way, we can see the solid shape in the different view. Okay, in the different view, we can see the solid shape. See, this is if you want to draw, this is a solid shape, and if you want to draw the front, then we have to draw three square. If you want to draw the side, then we have to draw two. If we want to draw the top view, then we have to draw the two. We have to draw the two view. Top view 1 and 2, 1 and 2. Side view, this one or this one. And what about the front view? We will see this. Side view means this side. You will see only two. Okay. So in this way, we can draw the different view of the solid shape. We can draw the different shape. So in the 3D object can be looked differently from the different position. So it can be drawn from different perspectives. This is how we look here. Top, front view, side view, and top view of this 3D set. Let's see one example. This is in your textbook also. Okay, let's draw one rub. One, two, and this will be this is a cube that how many cube we have seen? Made of 4 cube. We have seen 1, 2, 3, 4 cube. So if you want to draw in the side view, then how will you draw? Where is the side? How will you draw the side view? This is the side. Okay, these all are in the front. What about this? This is a top. So if you want to draw this side view, how will you draw then? We have to draw two shape of square in this way. Then we want to draw in the front view, then we have to draw here in this. There are three front square, 1, 2, 1, 2, 3 in this way. How will you draw the top view? Top view means here, this is the opposite of T. Okay, it's look like T. We'll draw like this. This is how it looks like. This is the top view. In this way, the 3D shape, when we see the 3D shape from different position, we can see in this form. This is a second example. We have to draw the side view and the top view, side view, and the front view. First one is a side view. Let's see the side view first. So where is the side? Side means this is the side. side, and this is a top, and this is a front. So this one is side. Then how many side you will see? We will draw here. There are 3 sides. 1, 2, 3. So we'll draw here 3. 1, 2, 3. Then second one is the top view. Top view 1, 2. We have seen only 2 tops. Okay. Then we will draw only 2 cube. And what about the front view? Let's see, 1, 2, 3, and 4. This one is a front view. Front view will be in this form. 1, 2, and this. This is a front view. Side view, top view, and front view. We can draw the solid 3 this type of solid shape in when we see in the different different position. Then we will see in this top view, side view, and the front view. So the next we will discuss about the solid around us. The solid we see around us are commonly in the shape of cube, cuboid, cone, cylinder, sphere, and hemisphere. That is half of the sphere are shown on. We are now going to discuss about the shapes of shapes of the solid. Okay, here is a we have already seen this is cube, cuboid, cone, cylinder, sphere. This half of the sphere is we call as hemisphere. Pyramid, prism. This one is rectangular base pyramid, and this one is a prism rectangular base and the pyramid rectangular base. So these are all the shape. Now we are going to learn about this. These are all the solid around us. Okay, we see the solid shape nested upon one another. For example, ice cream is a cone like hemisphere submounted on a cone, or a pillar like cylinder mounted on a cube. Many such combination will found around you. Look for them. Look here, this also. So again, we will see here Platonic solid. What is a Platonic solid? We will discuss here. Just like a polygon in a plane figure made up of line segment, only a polyhedron is a solid shape made of a plane surface. So cube, cuboid, pyramid, prism are all the polyhedra, plural of polyhedrons. So understand? Sphere, cone, and cylinders are not polyhedra. Are not the polyhedras. They are not the polyhedras. So what is Platonic solid? Now we'll discuss now. Just as a polygon convex only with equal side and equal angles are called a regular polygons. Polygons with equal side, okay, equal angle are called as regular polygons. So also polyhedras that is convex only with congruent face are called a regular polyhedra. That is, we can call it regular polyhedrons also. Understand? They are also called Platonic solid. Regular polyhedras or regular polyhedrons, we also call it Platonic solid. There are only 5 such regular polyhedras or Platonic solid. The face of Platonic solid and their edges and also their angle are congruent. So in this Platonic solid, that means that we will see again here the regular polygon. We have already understand if we have equal side and equal angle, we can call this regular polygon. And again about the regular polyhedrons, if the face of the polyhedron are made of complex congruent regular polygons such that same number of faces meet at its vertex, a polyhedron is called as a regular polyhedrons. Or we sometimes they also call as a Platonic solid. Understand? So here again, if we discuss about the cuboid, whether cuboid is a whether cuboid is a regular polyhedrons or not. A cuboid is not a regular polyhedron. Why? since its face are neither regular or the congruent rectangles. Understand? That means that it is not a regular polyhedron, because though through its faces are congruent, the vertex are not formed by the same number of the phases. So when we see this, if we see the regular polyhedrons, all the faces and all the faces should be congruent to each other. But in the case of the cuboid, neither nor congruent rectangles. So the face are not regular polygon because the face are congruent triangles. The vertex are not formed by the same number of faces. So cuboid is not a regular polyhedrons. So there are a few Platonic solids are there. This is a tetrahedrons, hexahedron, octahedron, dodecahedrons, and icosahedrons. These are the 1, 2, 3, 4, 5 here, 5 regular polyhedrons or Platonic solids. Next, we will learn about the face, edges, and the vertex of the polyhedras. All the polyhedras have plane surface, plane face. Okay, two plane face meet in the line known as, means if these are the known as edges, that is a line segment. The edges meet in a point called as a vertex, that is this is a vertex. A cuboid has 6 faces. Cuboid has 6 faces, 6 edges, and 8 vertex. Is a cuboid is a Platonic solid? No, it is not. All the faces are not in the regular polygon. So now here also it is proved that whether the cuboid is a Platonic or the regular polyhedron, then it says no, as all the faces are not in the regular polygon. Now again, next point, prism and pyramid are two important members of the polyhedras families. Prisms are the polyhedras whose top and the base are congruent polygon and the other face are in the form of the parallelogram. See, prism are the polyhedras. That means prisms are the Platonic solid. Okay, why? The top and the base are congruent polygon and the other face are also in form of parallelogram. So these are all form of the prisms. Here is a prism. Now this is the shape of the rectangular prism. This is the shape of the this is a triangular prism. This is the shape of the rectangular prism. This is the shape of the hexagonal prism, and this is the shape of the pentagonal prism. Okay, so let's see here how we can define this. You see this shape, rectangle, triangle. What about this? Their faces are in the form of what? Rectangular prism has 6 vertex, 9 edges, 2 rectangles, and the 3 lateral faces. And about this one is a triangular prism. In the triangular prism, there are 8 vertex, 12 edges, 2 rectangular base, these two sides, and 4 lateral surface. And about the pentagon, this one is hexagonal. Side of the base of the prism are 6. Okay, one, you see there are 6 side are there, so we can call it a hexagonal prism. So on, if the base of the quadrilateral prisms are parallelogram, then we can, if the base are the parallelogram, then we can call it parallelopipes. Okay, and this one is about pentagonal prism. See the base, first one, it has how many vertex are there? 10 vertex, 15 edges, 2 pentagonal base, and the 5 lateral faces. So this, we can say that this one is a rectangular prism, triangular prism, rectangular prism, hexagonal prism, and this one is a pentagonal prism. So why they all are called prism? Because in a polyhedron whose side face are in form of parallelogram and base are congruent parallelogram, base are congruent parallel polygon, is called a prism. That is why these are all in form of the prism. Did you get the point? So next we will have again pyramid. Let's see about the pyramid. Pyramid are also the polyhedra with a polygon as its base, and all other faces are triangle meeting in the common vertex. Let's see. These are these are all the shapes of the pyramid. The base of the pyramid can be polygon with any number of sides. The most common bases are square and a rectangle, but it could be pentagon, hexagon, and so on. What is the name of this? This is what is the base? Base is a triangle. Then we can call it this is a triangular pyramid. Base of this figure is a rectangular pyramid. We can call it a rectangular pyramid. What about the base of this pyramid? If you see the side 1, 2, 3, 4, 5, then we can call it this shape. This pyramid is pentagonal pyramid. We can say that this is a pentagonal pyramid. So likewise, prism pyramid are named after the base. See, in the prism and in the pyramid also, the name of this every shape of the pyramid and the prisms are named after their bases. A pentagonal prism has two pentagon as base. A rectangular pyramid has a triangle and its base, and so on. So is a rectangular pyramid a Platonic solid? A rectangular pyramid can be a Platonic solid if all its four faces are in the equilateral triangles. Equilateral triangles means all the triangles should be in the same shape, in the same figures. In the same length. So all the triangles should be in the. See here in the this is a rectangular pyramid. If we say that in the rectangular pyramid is a Platonic solid, then we have to prove that its all faces are in the equilateral triangles. Equilateral, it should be same side, same angles. So all the four sides of this triangle should be, face of the triangle should be in the form of equilateral triangles. Then we can say that triangular pyramid is a Platonic solid. These are all figure of Platonic solid we have discussed already. Tetrahedron means a triangular pyramid that we have seen. The triangular pyramid, its faces are congruent and equilateral triangle. It should be face, all the faces should be are congruent, and it is and also a equilateral triangle. What about hexahedron? Hexahedron, it is also the cube, and its faces are in the 6 square. And what about octahedrons? Octahedron has 4 equilateral triangles meeting at its vertex. Now you will see 4 triangles. So all the triangles are meeting in its vertex. Okay. Then the fourth one is dodecahedron. Dodecahedron, it has a 3 pentagonal meeting. So 4 pentagonal shapes are meeting in its vertex. Three pentagonals meeting at its vertex. Okay. Then icosahedron. Icosahedron has 5 equilateral triangles meeting at a point to form a vertex. Understand? These are all the Platonic solid of figures of the Platonic solid. Tetrahedron is a rectangular pyramid, and this one hexahedron means a cube and has 6 square. Octahedron means 4 equilateral triangles meeting at its vertex. Dodecahedron means 3 pentagonals meeting at its vertex. Icosahedron means 5 equilateral triangles meeting at the point to form a vertex. These are all the Platonic solid of Platonic solid figures of all the Platonic solids. Now this is the last topic of this visualizing solid shape. Euler formula. What is Euler formula? Let's see. Let us see the relation between the faces, edges, vertex of the polyhedras. Observe the polyhedras shown below. Count their face, edges, and the vertex. See, this is a formula of the Euler's formulas. Okay. This is the first one is a cube. It has 6 faces, 12 vertex and the 12 edges and the 8 vertex. So first, what Euler's formula says that faces plus here, in its case, faces plus vertex equal to edges plus 2 faces, should be equal. See here, faces, for faces and the vertex it becomes 14, edges plus 2 becomes 14. Then this is, we can prove, say that this can be the, this can, we can prove that Euler's formula. In this figure also, here we can say that face plus vertex, that is 11, edges plus 2 faces. Then you will see here again both sides are equal, okay, in this case also. And again here also, in this figure also, 5 face, 5 vertex and 8 edges, both sides are 10 10. So we can use to find out about the Euler's formula. There are two formula. You can see that faces plus vertex equal to edges plus 2 faces, or faces plus vertex minus edges equal to 2, face plus vertex minus e equal to 2. This is a formula of the Euler's about the relation between the face, edges and the vertex of the polyhedrons. This is a Euler formula named after the famous Swiss mathematician Leonhard Euler, a brilliant scholar who obtained his master's degree in mathematics at the age of 16. See, this is very young mathematician of Swiss. So he proved about the relation between face, edges and the vertex of the polyhedrons. By using this formula, we can solve few problems. Let's say now, by using the Euler's formula, we can find out vertex, faces of this group, one group, third group and the fourth group. What is the Euler formula? Says that face plus vertex minus edges equal to 2, or face plus vertex equal to edges plus 2. Now in this first column, face is 6 and the vertex is nil and edges is 12. And how will you find out the vertex? Now we are going to find out this vertex. Then the first calculation we can calculate here, f plus b minus e equal to 2. What is x? 6. Vertex means b. Edges means 12 equal to 2. Then again v equal to means what? These two, when you minus these two, you will get minus 6. b minus 6 equal to 2. Then b equal to, if you transfer this 6 this side, then you will get 8. The answer will be 8. Now again we can see here whether the answer is correct or not. See, vertex face is 6, vertex side now 14, edges plus 2 now 14. Then you can say that the vertex is 8. That is correct. Now second one, we are going to find out the face plus vertex minus edges equal to 2. Now what is face? Face is unknown. Then vertex is how much? 6. Then what about edges? 9 equal to 2. Then again here comes minus 3 equal to 2. What face equal to how much? 2 plus 3, that is 5. Now face will become 5. Yes, here we can prove here 5 plus vertex is how much? Vertex is 6, 11. Now here 9 plus 2 is 11. Now the answer of face is 5 is correct. Now Roman number 3, face plus vertex minus edges equal to 2. What is the face? 8. What is the vertex? 6. What about this one? E is equal to edges equal to nil, unknown, that is 2. Now become 14 minus e is equal to 2. Then minus e equal to how much? If you transfer this 14 this side, you will get here minus e equal to minus 12. Then e is equal to 12. The vertex will become, and the edges will become 12. Now put the value of vertex here. 8 plus 6 is 14 and 12 plus 2 is 14. Now this is correct. Now the last one, that is 4. That is face plus vertex minus edges equal to 2. Face is 5. What about base, vertex is nil, and then edges is 8 equal to 2. Then this b equal to minus 3 equal to 2. b equal to what? 2 plus 3, that is 5. The vertex should be 5. Now let's see whether it is correct or not. 5 plus 5, and this one is 8 plus 2. These are all correct. All answers are correct. By this is a Euler's formula tells about relation between faces, edges, and the vertex. Now we can find out figures of any vertex or any edges or faces by using the Euler's formula. The summaries of this topic is the R's three-dimensional set made up of all the polygons we call is what? Polyhedrons. And the polyhedron whose side face are parallelogram and base are congruent parallel polygon is called a pyramid. Prism. And the second one is pyramid is a polyhedron whose base is a polygon, whose side face are triangle having a common vertex called apex. Okay, and the fourth that we have discussed is that Platonic solid. Platonic solid are regular convex polyhedras. There are only 5 Platonic solid like, namely there are only 5 Platonic solid. Okay, only 5. That is namely tetrahedrons, hexahedron, octahedron, icosahedron, and the dodecahedrons. There are only 5 Platonic solids. And then the last one is Euler's formulas. Euler's formulas is face plus vertex equal to edges plus 2. VFE stand for vertex, face, edges of polyhedrons respectively. These are the few things that we should be remembered in this visualizing solid shape. So thank you student for watching my own YouTube channel. This is a lesson number 10. Lesson number 10, visualizing solid shape. Thank you.